Drones don't operate in clean air, and anyone designing them like they do is already designing them wrong. They operate in noise, congestion, interference, most of it self inflicted. And if you're designing them for a clean spectrum, you don't understand drones and warfare. Because in a congested battle space, flying is easy. Seeing clearly, that's the hard part. Welcome to the Swarm News. This is the show where veterans and engineers talk about defense tech the way it actually works, not the way it gets dumbed down online. If your systems only work in clean conditions, it doesn't work. It's a demo.
And I'm Vincent Lewis. And I'd like to say first, thank you for all those who have already liked, subscribed, and followed us. If you like our content, please, come back and watch it and keep up anything else or keep looking out for anything else that may be interesting to you in the future. Also, if you have the opportunity, go to the comments and put in anything that you like to see us change or actually like to hear us talk about. So, with that being said, back to you, Josh.
Yeah, so one of the biggest misunderstandings about drones is thinking of them purely physical systems. They're not. They're spectrum dependent systems pretending to be aircraft. They live in the electromagnetic battle space. They depend on communications, navigations, sensing, timing, all of it operating in spectrum that's already crowded and often contested. The electromagnetic battle space isn't a supporting detail, it's the fight. I mean, when that space gets noisy, everything downstream feels it.
Yeah. And from a systems perspective, that's the core issue. When you have several competing signals and other systems out functioning and trying to work together, to have your system work without having problems is a misnomer in the situation. You really need to think through your signals that could possibly get like interrupted or problematic, or your signals that could cause other systems to be functioning in a way that isn't supposed to be. So, say something simple is just having a spectrum analyzer to see what signals are out there. Being like in my home, I have my Wi-Fi, and having something like this that can give you just a simplified understanding of what the signals are, gives you understanding of what you may have to consider when you're in your home trying to build something out in the field, especially. And even when you're in a situation in combat, that becomes even more important because something like that could tell you where a drone is and something that could be coming up in your area. So understanding the spectrum and where things are is an important thing for not only just you, but anything for situational awareness. And understand a drone is basically a network or a node in the sky. It's working with other systems and or working to connect to a system to communicate to get either that information to yourself or to others. And that network coexists with other friendly systems. It has to work in civilian infrastructure. It has to work with commercial devices. And it also has to work against adversary emissions that are being put out and them trying to be jammed with it. So you need to understand your environmental interferences and understand that the congestion isn't a edge case, it's a baseline for whatever you're doing.
Yeah, so when we talk about noise, we're not just talking about electronic attack. Noise includes overlapping transmissions. I mean, it includes unintentional interference, spectrum reuse, and environmental effects, and degraded line of sight. Most systems don't fail dramatically, they fail quietly, slowly, and confusingly. That's the failure mode designers underestimate the most. I mean, they just don't take that into account. And it's what the operators have to deal with, and it's what they feel.
Yeah, technically, noise shows up as something that's a signal or reduced signals to noise ratio. So when you're looking at your system, if you're using a simple transmitter like a FR Sky transmitter or a radio master or spectrum transmitter or TPS transmitter. A lot of those have the ability to actually do a signal test to see if the transmitter and the receiver are actually working without any complications with the signal. You can verify before you even put that aircraft in the air if it's actually getting what it needs to. And doing something as simple as that can help you to keep your aircraft from crashing to the ground because or going into fail safe or having other problems to getting an erroneous signal. So figure out ways that you can look at what your signals in your area would be so that you can be able to work in an environment that is conducive to your system working properly, lack of better words. Because another thing that you have to consider is like for your GPS, for most commercial off the shelf GPS, you don't have to worry about timing. But in the military, we had situations where, like when I was in air defense, we had back in the day to input we had to set our GPS time to ensure that they were all in sync. Because if it was out of sync, that could cause the signals or your data to not be connected up properly and the system wouldn't work well. And you can connect your launcher to the shelter so it would work, but it would have other problems. So something like that back in the day was a problem. Nowadays, just making sure that your firmware is updated and that they're getting the constant signal data they're supposed to, and all looking at what they're supposed to be. And in a combat environment, that's just as important with now situations where you have systems where your GPSs can't be negated. Those systems have to be in a place to where they function in a better means to be non-jammable, and a lack of better words. And the danger part to this is that systems appear functional right up until they aren't. And that's the design assumption that gets exposed.
Yeah, I mean, detection in a congested environment. I mean, is it isn't about range or sensitivity. It's more about context. When everything emits something, the real question becomes what matters right now in this moment. Detection isn't about finding signals, it's about deciding which ones you can afford to ignore. That's a judgment problem, not a sensor problem.
Yeah. And from the technical side, detection is never a single sensor issue. It is the multitude of all your systems all in one. And no one sensor tells the whole story. You could have your camera saying that it's seeing something, whereas your transmitter is saying, I don't have it. It could be that there is a problem with the transmitter having clear line of sight to just the video transmitter could be possibly jamming or causing other problems or vice versa. On top of getting that information back to you and you have separate streams, is the redundancy can help and it could also be a hindrance because it means that you have more systems or more spectrums that you have to figure out if they're working like they're supposed to, and if that actually is a necessity that you need. So, like right now, when I used to do testing, we had three different signals. We had to worry about the transmitter, which is 2.4 communicating with a receiver that was on the system. Then you had your ground station, which was working on 900, which was communicating between your computer and the flight controller also to give back and forth transmission. And if the ground station wasn't typically working for our risk mitigation, was we didn't really take off unless we had the ground station working because that was the primary for putting uploading our flight modes, getting telemetry data, and seeing just the overall health of the aircraft versus the transmitter would also get that same information, but it was the controlling node that technically was the primary for the operator to actually communicate and control the aircraft. So it was nice to have those two, but if one was off, it kind of caused issues. Nowadays, you can have all those in one system, and it allows it to where it can transmit back and forth between both redundantly without you having to figure out which one is going to be working well. You have gives and takes. Whereas one system went down, I still had the control of it through the transmitter or through the ground station to control it. Versus where you have one where it's everything in one. If that all goes down, then you're kind of at a screw point because now you don't have any other way of communicating with it. So you have gives and takes that are good and bad. You just got to think about what it is that you want. And when you're dealing with clutter and false positives, overlapping signatures, and dynamic backgrounds can be a harm to what you're doing as your testing and your mission. And that's why modern approaches focus on correlation of confidence and pattern recognition over time and not instantaneous certainty. This is basically that certainty is what you want, but it can all be also a harm to you in the end.
Right. No, I agree with you on that. I mean, this is why perfect signal assumption fails us. One of the fastest ways systems fail is assuming they'll always have clean comms, stable navigation, and consistent telemetry. I mean, that assumption survives in the PowerPoint world. It does not survive operations. In a congested environment, links drop, latency spikes, and updates arrive late. Decision makers still have to act.
Mhm.
Clean comms are a planning fantasy, and brittle systems lose trust fast. Operators hate when this happens.
Yeah, and understand, nothing's perfect. We have, especially in the COTS world, systems work well. Don't get us wrong. It's not like you always going to have this as a problem, but if you don't consider it, you're going to have a problem when it comes up. And trust me, I've had systems where they work perfectly in testing before we get to the field. And then you get in the field and it's like, what the fuck? This hasn't happened this problem before. And from the flight controller not booting up properly to the transmitter just not connecting and having to reconnect to your receivers and RFD 900 just saying, hey, I don't have it, or your RFD 900 is working together, but your signal distance is just less than what it was the day before, and you had the week before it worked perfectly, flawlessly for the whole time going from one place to another. And mind you, you could be in the exact same place and everything works, and the next thing you know, it doesn't. So knowing your areas of what's going on is more important than just thinking that the system is reliable all the time. And technically, the resilience is a support to you, but it can be a dependency that if you don't understand ways around it, it can also hurt you in the long run. Systems could or should expect partial data. They should expect delays and updates to whatever is going on with the information coming in. Imagine for those who've ever worked FR Sky transmitters, remembering where if you're getting that information for your data packets coming in, hearing it partially come in, one saying you're at 100 feet, and the next thing you know, you get a ding saying you're at 50 feet, and understanding that's erroneous. But knowing that you can see from the computer that is showing, yeah, you're still at 100 feet. The transmitter may be saying something, but at least on your visual screen, you can see it's still showing 100. So differentiating between those problems is a need for understanding your consistency in inputs or inconsistency in inputs. And good design asks for, what do we do that gives you confidence when it drops to a low confidence level? And if your system has no answer for that question, it is not an option. It is not a system that is really operational. It is something that needs to be focused on and come to a risk management problem that can be resolved.
Yeah. So my question to you after hearing what you just said is if I'm getting a false reading, how do I know which one's false? If it's the
Mm.
mission control or if it's the telemetry that's being reported back to me. Like if I'm at 100 feet and it's telling me I'm at 50 feet, like which one do I go with and how? I mean, is that just a skill set that you learn over time, or like how do you know which one you're going with on that?
To simplify that, what we learned or what I learned from it is that one, the attention to detail comes into importance because you have three different factors that can help you out with this. One, after you get to flying, especially for small drones, you start to realize what altitude is, and especially if you see it, you have a visual line of sight that you typically always have to keep, so you know what it should be at all the time, and you can see if the transmitter is telling you, "Hey, on the screen's at 100 feet," but then you're getting a audible warning that's saying you're at 75. then maybe the audible warning is wrong, especially after you getting constant updates. Because the good thing about the reason we had the audio updates is that I didn't have to look down at my transmitter to verify that information. The audio update was to give me an understanding without having to look down, so I could keep my eyes on the aircraft at all times, but also having a ground station that's set up with someone on it so that the computer gives that same data to them. You have a person that doesn't have to always call out your signals. So in this case, say in the case of has we're going up to 2,500 feet. As I got up there, I'm having to keep a heads up on it because I'm trying to make sure that at 2,500 feet that the aircraft doesn't have anything else in the sky. I'm not worried about it actually having any other issues that I need to take control of it quickly for. And I don't have the time to look down and say, is this where it's supposed to be at? Or am I having other issues? Because say it comes up with the fault, I have the transmitter kicking out what that fault is, like telemetry low. I can get my operator that's on the computer to say, hey, your signal's good. We still have it here. Your transmitter is saying it's low, but in actuality, you still have like 3 or 4 bars signal. So
Okay.
that's how you can know by yourself whether it is or isn't proper. So you get a good feel for it through those type of situations where as you build and you go through design and flying it, it comes natural, whether it's the system working, whether it's a actual hardware problem, or if it's something else. Sometimes that answers your question.
Yeah, no, it does. Thanks. So let's move on to adaptation without details. And we're not going to talk about how to adapt tactically, but we can talk about what good adaptation looks like. At a high level, adaptation means prioritizing what matters, accepting uncertainty, avoiding overreaction, and maintaining decision discipline. Noise doesn't kill missions, overreactions do.
Yeah, engineering adaptations is a thing that's about behavior, not tricks. Good systems recognize degraded conditions, communicating uncertainty clearly to avoid false perceptions of functional work that's our functional systems that may seem to be functioning but aren't working well. So you need to maintain a core functionality that you have expectations, like I just said a little while ago. You have systems in place that allows you to know whether your system is functioning, whether it be a visual look at what's going on and you know how it should be flying, to your system giving you updates to let you know, hey, you got a subsystem that's not working, GPS loss, or you have a signal loss because of you go into a specific area and it knows it and it goes into failsafe to ensure that it keeps going on, continuing the mission or stops. And adapting is about more than just doing more with less. It's about doing things deliberately.
Yeah. Poor design is a big issue. So congested environments don't stress all systems equally. They punish the bad designs first. They deal with systems that rely on single points of failure. Constant connectivity or a perfect synchronization collapses quickly. And when they do, operators lose trust immediately in all of these systems with these kinds of issues.
Yeah. Have you, in your time doing things, because you're a signal SME in this, a lot of situations, what are some things that you've seen that have been situations where you would preferred it to be working in a better way than what it has been? Has there been
Um,
thing that's been should be functional, but or could had separate risk management type situations that should have been put in play, or things that just you would have expected to work better than it did?
I mean, I'm going to say this. One of the things I hated the most when I was dealing with this is we would have different companies that built the different parts. So we would have somebody that built the sensor that we were using to collect in the environment, but we were using somebody else's hardware and software to actually do the actual, like, hey, is this looking at the parameters of the signals? Well, sometimes they didn't talk to each other properly because a third party was the one that was designed that came in to make sure that the data got from the sensor to our ground. So now you have a third company in there, and then the things wouldn't talk properly sometimes. And when we tried to get them to talk properly, or we tried to get people to help us fix it, the word proprietary came into use, and that word is the word I hate more than anything else in the world. Proprietary information. I'm sorry. Like, if you're buying something and you're selling something to the government and it has to work, that word should not exist. We should all the data should flow evenly, and I should be able to tell this company, and this company, this is what each of y'all are doing. I need you to make your shit work right, and it needs to go, and it needs to be flawless because I'm running into issues because y'all don't want to work together properly. Like, that was always my biggest issue. I hated it with a passion, and I still hate it today, and I'm not even doing that stuff anymore.
No, I
So
feel you.
I think that was my biggest issue with all of that, is dealing with like the lack of communication between the companies to make things work efficiently because of proprietary data and information. And it's just it wasn't it drove me crazy. But
No, I feel you. I completely get where you're going with that because it's somewhat that way in the conventional civilian side of it. I mean, most of it's easier because you got workarounds, but like you're saying, to be in a combat situation, you don't have Joe Smo work. Hey, I got to call up in the middle of a firefight and say, "Hey, I need you to give me your whatever widget connection software to get connected because I can't get it to be done right now." That is the worst
yep,
time to have some shit like that happen. And technically, congestion exposes that architecture.
yep,
It gives you that understanding that your coupling overlap systems are the problem, and it's poor prioritizing how your system, even though it may be proprietary, works with other systems, because what you should have done in the first place is make it to where this is an open source situation,
yep,
and combining it with a well-designed system that no matter if it's degraded or is not working perfectly, it functions. And being that that's easy said. I know someone's probably like, that's easier said than done. Have you done it? Yes, we've had to take other things, and that's another part of design features. As an engineer, you got to be able to say, what does the end user need more than me trying to keep my life settled with whatever, because you're trying to provide this as a lifesaver to someone on the other side. So
yeah,
poor design systems fail you, and if they fail suddenly, that's not good, especially in combat. So it's not just in a situation that you're thinking of just right now because it's working in the civilian side. It's got to be something that works in the combat side of life too. Civilian, you got leeway. If we're out here every day, you can say, "Hey, I got something," because there's not life and death. That's the key. It can't be life, and that difference matters more than peak performance.
yep. So let's go ahead and we're going to move on to like responsible discussions. And this is where the public conversation often goes sideways. People want specifics. Professionals understand that broadcasting detailed tactics creates more problems than it's going to solve. I mean, what matters publicly is just understanding the challenges, shaping the requirements, and improving the design thinking, not handing out the playbook on how we're going to do anything tactically, because why would we want to give the enemy our handbook on what we're doing and how we're going to maneuver?
Yeah, and engineers carry that responsibility of ensuring that your system functions in a way that the end user and your operators expect. And that design and the congestion means that, yes, your system may be in a place to where it cannot work extremely perfect, but you have to account for it and ensure that no matter what, it works for the end user. The end user is a priority, and building it with margins and understanding what your system is capable of in the long run is more than just embracing uncertainty. It's actually building into helping you be at a place where you don't have to worry about obsolescence, because now you consider the whole outcome of whatever situation is, making it to where if you know that there's a problem, you can update and bring that into play later so that your system can stay on the battlefield, stay working functional, and also stay in a place to where even in a changing environment in the civilian sector, you're able to now be prepared for later problems that you can anticipate is a better aspect of what I'm trying to say. Just anticipating those problems and making your system be able to be aware or functioning as is even better. So you'll never have an actual perfect system. And if you do, man, you're fucking amazing. Let's just put it like that. You came up with the answer to it. And not saying it's not possible. And if it is, hey, I would like to talk with you on it. So let me see.
Yeah, so here's the bottom line, right? Fail because of the environment overwhelms to any assumptions that anybody has created. The signals matter, the noise matters, and how systems behave under pressure, how they behave under the pressure matters the most.
Yeah. From engineering, seeing it clearly in a congested environment requires integration, correlation, restraint, and resilience. You know, we aren't working in perfect information. You're working with what you have. Trust me, especially if you're getting something from the government at times, you may not get all the things because they may not even have it all the time. So you have to think outside the box. And that's the key. Thinking outside of the box and being prepared for what is the unknown versus the known is the most important. And a lot of times you have a sight picture that will be there ahead of the time that you can go into and say, they may not see it, but we do. This is what's going to happen, and provide that as a source of support going forward, and help them to get ahead of the game. Because say the enemy sees it, they're going to definitely take advantage of it. And if any competitor also who's out there who sees these things, they're going to take advantage of it just as well. So it works on both sides, combat and the civilian side. So ensure your system can survive no matter if it's on the combat field or in the combat or on the civilian sector.
Yeah, so I'm going to leave you with this. Confidence without context is how systems lie to their operator. In congested battle spaces, clarity comes from understanding limits, respecting uncertainties, and designing for degradation. That's not pessimism, that's professionalism. If this episode helped you think differently about drones, signals, and noise, share it with someone who still assumes clean conditions. And if this perspective matches how you think about defensive tech, please subscribe, like, all that kind of stuff. Follow us. This is exactly what we do every week, and we will see you next time.
Again, take care. Talk to you guys later. Thanks for showing up.